So as far as the design of our roll forming process goes, one thing that was beneficial to us was using an iPhone app to help calculate the amount of spring back the material had. So the first thing that we did is we took a piece of the flashing, bent it up to 90 to see how much it springs back, and then we subtracted that from 90 so that it would come back.
Instead of using ABS material, we could use PLA material on the 3D printing parts because we have so much warping in it that we can reduce that by doing PLA material.
And the last thing that we would want to change is there's a lot of movement in the material as it's going through the process, so adding some kind of rollers or supports on the side to keep it straight as it goes through would be very beneficial. A couple more important details we thought we might add. We did use the school's 3D printers, and we chose a 20% infill with normal quality. The total print time was about 40 to 45 hours for all of our rollers, so it did take quite a while. And for the testing of the spring back, we took an average of 4 tests, bending it up to 90 degrees, and then we took pictures of those profiles and imported it into an app called Angle Meter. And we found that there was about 17 degrees spring back, so we took that and subtracted it from 90. Moving on, the flashing size was an issue as well. We had to trim it down so that it would not come into contact with the shaft because on earlier tests it was bending it. So this could be fixed by either making larger rollers or trimming the flashing down. And due to time restrictions, we were not able to make any guides for the metal as it goes through the process. And the last thing we'd like to add is that all of the team members were helpful. Anna Brezina was not able to be in the presentation, but she was there for the design and the creation of the rollers.